Hi, everyone. I would like to round up week one with a short video about modern search engine architectures. In the lecture recordings, we have talked about the Google architecture in the early days, and we show you these pictures. Later on in the live question answering session or lecture, we started from this architecture and we commented how this architecture has changed over time to allow for improvement in search technology and scalability and different use cases. I would like now to share with you some thoughts about the latest changes that have been around search engine architectures due to the new approaches, new neural approaches to search. So over the last 5 years, AI technology has substantially progressed with the introduction of neural models that we will talk towards the second part of the course. And this is not stopping at all. See, for example, the introduction of ChatGPT last November, and the recent introduction of Google's Bard, and the building of search services on top of these large language models. So these technologies are disrupting how we think about the architecture of a search engine. So I would like to share with you some thoughts that were given this week at SIGIR 2023 in a keynote by Mark Nyyork. Mark is a distinguished research scientist in Google DeepMind, and he has managed a lot of Google research in the search space. So a traditional search engine architecture looks something like this, right? We have some content, we have some crawler that in an offline time, crawling time, acquires that content. The content then is passed on to a corpus builder that builds a corpus. There might be the cache of the search engine. It might be the list of URLs. And the content is also passed to an index builder. The index builder is responsible to build the inverted index that then is what is used at online at query time to find appropriate content to provide to the user. So at online time or query time, a user issues a queries through a search front end. The queries goes to the index server. The index server is responsible to interact with the inverted index, find and rank documents, and these documents then are through the corpus server are served to the user, whether these are 10 blue links like in a web search or are actually records, documents stored in the document database, in the corpus database. So this is a traditional lexical retrieval system, where lexical means it's based on the matching between a query word and an index word. Now, recently, we have seen the introduction of deep semantic retrieval systems. So these retrieval systems still have a corpus builder, still have a crawler to acquire content, a corpus builder to package the content ready in a corpus for serving later to users. But it replaces the search mechanism, it replaces the indexing mechanism by a component called the document embedder. The document embedder is responsible to take the content passed by the crawler and build a vector representation or an embedding representation of that document. So that's a vector of, in the case of BERT, we are talking about a vector of 768 dimensions, but other language models, other transformer-based language models will have different dimensions. And these vectors are then stored in a vector database. And when a query comes in at online time, the query comes in through the search engine front end. The query is passed to the embedding server. The embedding server is responsible to search for, is responsible to encode the query into an embedding, into a vector, and then is responsible for searching through the vector database. That's typically done through some form of approximate nearest neighbor, ANN search. Once documents are ranked, then you might go to the corpus server to get the URL of the documents, and this is what you serve to the user, so you might actually get the actual documents you have on record. Okay, so that's the deep semantic retrieval system. The matching is not done at lexical level, it's done at semantic level, it's done at this latent vector representation level. Now, we have seen people changing these, mixing these two approaches, the lexical and the semantic, into what is called a hybrid type of architecture. In this hybrid architecture, you have the traditional corpus builder and index builder, but additionally, you also have the document embedder and with the associated vector database. And when you get a query, the query goes through both the inverted index and the vector database. You compute the matches in that way, and then in somewhat you fuse the results, you put together the results. We will see how we do this, and we will see how we do also document embedding later in the course. Now, an example of such an architecture has been kind of pictured by Facebook, again in a recent paper they had, a CIR this year, where they disclose how the Facebook content search works. So I put that link there for you. If you're curious, you can go and read how the search at Facebook works. So their problem is that they want a highly personalized search engine that needs to serve billions of queries every day. And these queries are aimed to find results from a large scale of candidates, right? A huge amount of content. So they need search that not only is effective, search that is high quality, but they also need search that is efficient and scalable. So search that can be run fast and can run across a huge amount of document. And the underlying architecture they use is a search engine that is capable of both Boolean matching and approximate nearest neighbor retrieval. So the Boolean matching requires lexical capabilities. We will see it in a couple of weeks, what Boolean matching means, but this is matching at the token level. And the ANN, I already explained, it's a matching at a latent vector level, at an embedding level. And that's your semantic type of matching. And so this is telling you, if you read the paper, you would understand that Facebook is using some type currently, is using some type of hybrid lexical semantic approach. Okay, finally, with the really recent introduction of large language models such as ChatGPT, GPT-4, BARD, and so on, we have seen the architecture of search engine to have evolved further. So we still have our content and our crawler that is going on at the offline time, but then the content is not only passed to a corpus embedder, an index embedder, and document embedder, but is also passed to a language model trainer that is responsible to train the language model on the data that your search engine is attempting to serve. And then at query time, the query passes through the front end, and then it is sent to the inverted index and the vector database to do some sort of retrieval. These retrieval, the signal that comes from the index and the vector database that might be fused together in some way. Then the top ranked documents are retrieved from the corpus and are passed to the language model to generate some type of synthesized content, some type of synthesized answer. So this is, an answer or a summary or an answer that is granted, is attributed to specific sources. So this is the architecture of a retrieval-augmented generative question answering system. And if you have access to the latest version of Bing Chat, or if you have access to the Google Bard type of review, you will see that that's what's happening in the background. You will notice that because you're sending your query, and what this system are giving you an answer that is not pre-built and is not extracted from a specific document, but is an answer that is generated on the fly from the language model. And then in that answer, you will see it has been attributed. You will see the links to sources that have been used to provide this answer. And these sources are what the search engine retrieved through the inverted index and the vector database.